I found out about Noah on his YouTube channel where he has got a wealth of information. And I highly recommend to everybody listening that if you are looking to learn anything about computers, go and check out his YouTube channel. He's got so many different avenues you can go down. And one of them is MLOps. And he's just very, very generous with the content that he provides and his knowledge. So check that out. Today, I am joined by none other than Vishnu. And as usual, I say this all the time, but I really believe that we are in the presence of one of the greats today with Noah. He is absolutely just an incredible person. And so that you all can understand how prolific this man is, he is teaching courses at UC Berkeley and Northwestern, and he's got at Duke, and that's just like a few of them. That's not all of them. There's a ton of other courses. He's got uh, all kinds of certificates with all the major cloud providers, and then he has been in roles from CTO to head data scientist to general manager. I mean, the list goes on. The bio on this guy, I think I could spend the whole hour just talking about what you've done, Noah. And it is incredible that you are taking the time to talk with us today and just dive into this ML ops. So, without further ado, Noah, thank you so much for coming on here and joining us.
Thanks. Yeah, I guess that's the advantage of getting older is you do a lot of stuff.
It's compound interest, right?
Yeah.
Yeah,
Absolutely.
and if anybody wants to check out everything that he's done, you can head over to his website, which we'll leave in the description below, or you can just go to noahgift.com. That's an easy one. It is easy to remember. So you've got all kinds of courses, you've got all kinds of videos that you're putting out, books. I forgot to mention you are putting out a book. What is it? For ML
Yeah.
Ops this year.
Yeah. There's a book that I'm writing currently that should be done in the next 2-3 months called Practical MLOps.
There we go.
And that's with O'Reilly. And the co-author is Alfredo Deza, who also did Python for DevOps with me for O'Reilly.
Nice. And so one of I guess the main theme that Vishnu and I were thinking about kind of framing this around is because you have your company right now, right? Pragmatic AI Labs. And I love the title pragmatic. I love that word in general. And the idea of this O'Reilly book, also practical ML ops, I think it's really easy to get lost in the weeds and go down rabbit holes these days. And then the rabbit hole leads you nowhere, especially when it comes to something like an emerging field like ML ops, right? And so I'm wondering for you, maybe you could just start off and give us your opinion on how we can stay pragmatic when it comes to ML ops.
Yeah, so I teach, I'm actually teaching today. I'm teaching a course at Duke in cloud computing where we do ML ops in the course. It's called Cloud Computing for Data Analysis. And my recommendation to students is to think about machine learning almost like a mobile app or a database, or some component where it isn't necessarily the whole thing that the whole problem that you're solving. And I think what I've seen when I see a lot of interest initially into machine learning is, and I've had a spectrum of students, and also when I worked full time, was that it's easy to get caught up into Kaggle, for example, or predictive value. And there's a really good example of this in the last probably month or so. The documentary, if you haven't taken a look at it yet, called what is it, The Social Experiment? Is that what it's called? Social Experiment? And they talk about
Social
how
dilemma.
social dilemma. There we go. Social dilemma, where there are literally, I don't know. I know at least two myself, people that have PhDs from Berkeley. No, I know three people that have PhD in computer science from Berkeley that work at Google, that work on things like recommendation engines. And yet they served out more traffic to Alex Jones, flat earth theories, and QAnon than they did to like New York Times, Washington Post, Wall Street Journal combined. And so that, I think, is an indictment of the approach that was used. And I think it was an incorrect approach. And it's that if you're so stuck up on the predictive power of what you're trying to solve and not thinking about the real thing you're trying to do, that's how you get into a situation like that. So I think, in fact, the deeper you go into predictive power and you only stay there, this is the result. And I think the result is very bad for society. And so the practical approach is that you kind of treat all things equally, where, hey, what, do the customers that I'm building a solution for, are they going to like the product? Is it ethical to build it? I mean, it's easy to get kind of hand wavy and say ethics, but I mean, come on, you're literally indoctrinating people to believe in flat Earth. And in fact, we just saw, a bunch of people truly believed that they were helping overthrow the government, and people died. I mean, that's not squishy. That's a specific outcome that was focused on only the predictive power of a problem. So I think it's really not giving the machine learning the center stage. I think is the solution, to be practical, because it's one of many pieces in a problem. And if you can't solve the other 10 pieces, like user experience, repeatability, data drift, all those kind of problems, then you're really building something that, even if it does have extremely high accuracy, could be catastrophically bad.
Yeah, it makes complete sense what you're saying. And it really comes to this realization, I think, that we're all having now, which is, it's not just how good a model is, it's equally as important as how that model is used. I mean, that is what the operations component in machine learning and MLOps is supposed to be, how the model is used. And you mentioned one thing about machine learning systems needing to look more like traditional software systems, like databases and mobile apps, at least, conceptually, because of that need for reliable operations. That's something we talk a lot about in our community, on the podcast, on coffee sessions. It's kind of the mantra of our group. My question to you is, in your courses, how do you teach your students on what to prioritize to learn when there's so much content out there about modeling and predictive modeling and the value of working on that versus maybe how traditional software engineering principles apply to machine learning is less clear? How do you give them a framework for that in your classes?
So what I've gravitated towards is telling students to take a model that's already been trained somewhere. So go to Kaggle, just download it, and or use AutoML. Go to Google AutoML Vision, train a model, download it, TF Lite, or go to Apple has what is it again? the GUI that you can just click, you can just drag stuff onto it. I think CoreML, CreateML, right?
Yes.
You just literally just drop it on there, and then just get that work, get the feedback loop working before you get too deep into the weeds on the machine learning model, because to me that's the basics. It's like it's like if you're into running or riding bikes or swimming or something. If anyone's ever run a marathon, you can't just start going, hey, I'm going to get 6-minute miles for 26 miles. That's not how it works. Like you first, can you even do 26 miles before and I think that's the machine learning component of it, is that it is, if you first make sure you understand how to put it into a web app or put it into a mobile app, and then also you have a feedback loop where there's a continuous integration system as part of it, that to me is really the foundation that's necessary. And that is exactly what I teach in every course that I've built, is that you need to get continuous integration, continuous delivery setup, and you really don't necessarily at first need to know anything other than the machine learning model is a file or it's an endpoint. Then once you get that set up, then I think, sure, you can go in and, tune the knobs and get more in depth in it. But yeah, I would even say that it's interesting because there's a disconnect between a lot of people that are interested in data science. They want to be a data scientist. And then what happens though, is that if they don't have a foundational knowledge of DevOps, they could be really in trouble at an organization because they require, let's say, a dozen people around them to get anything done. And that's, for anyone that's had, let's say, 5 years of work experience or more, you realize that's basically the kiss of death for your career, right? If for you to be productive, there has to be a group of people around you at all times. That's not a good way to start your career. So I would say the antidote to that is, if you have an understanding of DevOps, then it's going to be much easier to do data science at scale.
I think the principles that you're teaching and that you're mentioning that you clearly impart to your students are great. One of the community members in our group, Laszlo, he has a great quote, which is, 90% of MLOps problems are data science writing bad code. And it's just facetious, but it goes to show that if you don't necessarily have those principles in place or have a good understanding of what that looks like in the context of software delivery, you can end up creating more problems than you're really solving. And that's not the position you want to be in. Related to this, on a principle level, this makes a lot of sense in how they work with machine learning. How do you reconcile how early some of the tooling for these principles are, and how perhaps even immature they could be considered? What kind of tools and stuff do you tell your students to use in their courses?
Yeah, I'm a little bit skeptical of some of the tooling currently. I think there's some nice things about things like scikit-learn, for example, in that it's a couple lines of code and you can create a classification model or do clustering. The issue is that at the academic level, a lot of times people assume that that's what they're going to be using in their job, and scikit-learn and pandas is really not going to work for many companies. It's not a big data tool. And so now you've got yourself in trouble, is you assume that you can use those tools. Maybe you will, but a lot of times you have to use a platform like AWS SageMaker or Microsoft Azure ML Studio or Google AI platform or Spark or something like that. So I think that the tooling is still pretty weak. And I think that is an issue where I would recommend that if you're working at an organization that has, let's say, 20 or more people in it, probably you should use a cloud-based tool, or a open source framework like Spark ML, just because you're most likely going to have less pain and suffering if you're dealing with data at scale. If you're just doing dashboards, or you're doing ad hoc analytics on small data, then sure, the academic type tools like scikit-learn are reasonable. So that's one component of the question. The other one is that I also am deeply skeptical that a lot of the work people are doing currently they'll even need to do in the next 2-3 years. I mean, I'm 45, so I've been around for a bit, and what I've seen in my career is that everything is automated. I mean, in fact, I worked as a teenager. I worked in television, and I grew up near Hollywood, and there was editing systems that were linear editing systems. You had to have 2 tapes to make a dissolve, and all this. I mean, we're so far beyond that just in 25 years. It's hard to even describe the changes, but things became digital and automated, and now you can edit things on your phone. You don't need any of that stuff, and you could do 4K editing on your phone. But same thing with machine learning. It seems really unlikely that all of this stuff people are doing on Kaggle, for example, will even be related to what they're doing in the workplace. Like, how could it possibly make sense that you're going to do all of this like hyperparameter tuning and like cleaning and all this stuff, where there already are tools where you click a button and it trains a model. So I think that's the wake up call that many people that are doing data science are probably don't want to hear, but should hear, is that if you're focused on the nitty gritty details of like the technique, and the technique is focused on something where it more than likely is going to be automated, your skills won't be that relevant. But if you're focused on the solution, then you don't care how you got to the machine learning prediction or the machine learning system. So I that's what I suspect is the AutoML components are going to come very fast. And it just, I don't know, my intuition tells me from seeing so many different things automated in my life, or same with cloud. Like I remember, I'm old enough to remember when I had bosses that told me the cloud computing is a bad thing to do. You know, our company can't do it. And they're like Fortune 10 companies like, oh, just can't do it. You know, cloud's bad. Same, I hear the same kind of talk about AutoML. It's like, well, I'm pretty sure you're wrong. I'm pretty sure that we're going to click buttons, and that's how we're going to do machine learning.
The quote that you just gave us, I think the work we do now is not the work we'll do in the future. I think that's a great point. And I think it's something that's been mentioned at the margins, but not anything I've heard with as much clarity as you've put it. And I think you're right in large part. I mean, even when we look where we were 5 years ago with just machine learning, right? We were working with very, very different frameworks. I mean, TensorFlow and PyTorch became popular, you know, now in pre-2014, I don't think anybody was using them. They were using things like Cafe, right? And so with that in mind and keeping that in mind, I think it's a great point to really focus on the solutions and not just the technique, and not just the, can you do this one step really fast, which I think a lot of times we focus on.
Yeah, and there's so many. You've been dropping quite a few bombs here, and I've been taking notes because it's really nice to see the idea of like, hey, just figure out if you can run 26 miles before you even go out and try to get the strongest and the best equipment for marathon, and you buy your like new suit and you download the app that's going to make you like check your times and all that. Just like go out and see if it can get there, and is the model doing what it needs to do, and then you can figure out the rest. And like you say, the goal, like not forgetting about the bigger picture, is so, it's so easy to say it, right? But it's so difficult to do when you start getting into the weeds on that. And I think that goes back to the whole idea. What I am assuming is the pragmatic part of this whole AI, like being very pragmatic in, hey, does this work? And how does it work? And then asking some really difficult questions in the beginning, like around ethics and that stuff. And I wanted to just mention that my neighbors told me today, so I'm in Germany, my neighbors just told me, I think they're going to close the gas stations and the supermarkets. So go gas up on your stuff. I was like, what have you guys been watching? How are they going to close the gas stations and supermarkets? Then how are people going to eat? But that's what happens when you get too many bad algorithms recommending too many bad videos on flat earth and all this. So anyways, that was a bit of a tangent there. And I wanted to jump in. Sorry, I cut you off, Vishnu. I don't know if you had anything else you wanted to mention.
I think the thing I was going to say is actually, I'm actually a student in one of your courses on Udacity on cloud DevOps, which is a great program. Yep. And I'm really excited and able to apply those lessons every day. I think your point about the cloud providers and what they're doing with AutoML and these tools are spot on. I mean, in your opinion, we talk a lot about this in the community, and I know our listeners will be really interested in this. If people have different GCP, AWS, Azure, they're using different platforms. You seem to have experience across all three, right? There are 2 degrees on Udacity that you've put out. What's your opinion on the relative merits of each, and where have you seen particular strengths?
I think AWS definitely is the leader, and it's a pretty safe choice to focus on AWS, and I don't see that changing anytime soon. So I think that's probably the place to start if you haven't started anywhere. And then if you get a certification for AWS, they pay very well. In fact, you could be a high school student and get a AWS Solutions Architect certification and probably get a job for 6 figures, which is, interesting. And I think not a horrible career pathway to consider doing. Again, I mean, I'm teaching that in college, but I think we should be open to letting people do whatever they want and start making money early. I think there's a lot to be said for that. Or even, working while you're in college if you want to stay in college. But I'd say AWS is probably the number one. Now, I think Microsoft is doing some stuff that is, I like the Azure platform. Some of the tools like Azure ML Studio is pretty good. It's a pretty good product, and the machine learning automation they have is pretty good too. The SDK, all this stuff that they have. So I would say they're probably number two, and then Google is in last place. And there are some things that are nice about Google. I think the Google App Engine is nice, and some of the AutoML stuff they have. Yeah, BigQuery is pretty nice. Like they feel like they're more like a la carte offerings where, maybe you would use BigQuery alone and use it with, let's say, Google Data Studio but maybe your core platform is Microsoft or AWS. So I would say that might be the solution if people really like one product on Google. I don't see it being the end game. It does everything, but some of their products are good, like you mentioned. Like I think BigQuery is another good example of a really good product.
I'm wondering, you kind of said that really quick, like AWS is the best in your eyes. What makes you give it the crown?
Well, a few things I think that are interesting about AWS. One is that the culture of AWS is different than the culture of Google, and I can't comment on working at any of I have not worked at any of those 3 companies. I know people that work at all those companies. I don't know if I would be a good fit to work at AWS, but as a customer of AWS, their culture is basically make the customer, have great products. Google's culture is not that. Google's culture is like, hey, let's try some products out. Oops. Oh, or there's a sharp edge there. Oh, well, yeah, we may or may not fix Google Hangouts in the next 3 years. So I think the big difference is that most of the sharp edges are done or are solved on AWS. I mean, they have products that do have issues like, they'll be in beta stage and things like that. But for the most part, things work on AWS. Also, it's a comprehensive solution. So, there isn't going to be a gap in virtual machines or networking or, they pretty much always have everything covered. And then in terms of pricing as well, the pricing really is pretty clear with AWS, and it's a lot easier to see what's happening versus Google or Azure.
Interesting. Yeah, I could
My
see
experience.
that. Yeah, and as far as like, we had Luigi from ML in production on here a few months ago, and he was talking about how he studied what SageMaker was doing and what AWS was trying to do with SageMaker just to get a better idea, like going back to this, having that DevOps mentality. And one of the nuggets of wisdom that you dropped earlier of like, if you need 5 people to do your job, that's the kiss of death for what you are trying to do. So as a data scientist, if you don't know what is actually going on and you're just relying on all of this other stuff or other people to help you out and make you valuable at your company, it's never going to work. And so I'm just wondering, like, when you're looking at SageMaker and just AWS in general, I guess it's more the ecosystem that you're looking at, right? You're not even looking at one of these tools. You're saying how everything, if you just had to choose one cloud, throw it all on AWS.
I think so. I mean, because you also can bet on the fact that they're going to keep improving. So, for example, excuse me one second, AWS you know that their serverless offerings like AWS Lambda, step functions, all these things are always going to get better. There's this like constant, let's keep making it better. Let's keep lowering the prices approach, where I don't see that with, let's say, the Google Cloud. Again, there's some great, you'll get surprised. Excuse me. You get surprised with, let me just drink a little bit of water.
Yeah, no worries.
Yeah, so you'll see that with Google Cloud, where occasionally they'll come off with like an incredible product, like Google BigQuery, like incredible, or Google AutoML Vision, incredible product. But it's not like you can bet on that. where AWS across the board, it's just consistent, like product releases. Every product they have gets better. So I think that's really the core difference between looking at AWS in particular and looking at Google. Now, I would say that Microsoft is going to give Google a run for their money, in that if you look at the ecosystem around the Azure cloud itself, like GitHub is pretty good. I mean, that's a great company. The GitHub Actions, the SaaS product they have is great. I know a lot of people say bad things about Microsoft Teams, but I think it's actually got some promise to it. There's definitely some things that are nice about Microsoft Teams. So if you look at the LinkedIn is another one. I mean, they have some awesome tooling and awesome products. So I think that that's probably going to be the big competitor. They got the contract with the government for defense contract. I think that it's a viable option. I think the Microsoft Azure is a viable option. I think Google will be a niche product, which again could have some great tools, but it'll be the part of a multi-cloud solution for a company. But it's not going to be, everyone I know that's had only the Google Cloud has not stayed with it.
Yeah, I think the key point is, whether the people at Google feel it or not, that you and I feel this way about Google's reliability speaks volumes. And I think that's the issue. And I think you're completely right. When AWS releases a product, that will have consistent updates. That it will have a certain level of documentation. That each widget looks a lot like the other in terms of how they make it fit into a pipeline or into a number of boxes. We use AWS at work. And as I was listening to you talk about the different cloud providers, one thing we talk a lot about in our community at a high level is just architecture, right? System architecture, and thinking about that, what different tools and what different processes should link together. And I kind of want to ask you at a very general level, what advice would you give to ML engineers who have spent the last couple of years really building models and are now starting to think more about the ML piece, and think more about the architecture piece, and they're perhaps into their career? How would you advise them to go about starting to get into architectural thinking about machine learning systems, with your perspective as an educator?
Yeah, I think that it's a good question. Let's just, since we're talking about AWS, I think it's not a bad idea, or Microsoft. Let's take those two, right? Those are the top two clouds. Is that it's not a bad idea to get certified. I think that a lot of times someone has a master's degree or a PhD, and then they're like, "Oh, that's beneath me. I shouldn't get AWS Solutions Architect." I would say you should. And the reason why is it'll give you a test of your knowledge, or at least do it once, get one of those certifications. Because what you'll realize is that there are some concepts that are actually pretty important, like elasticity and high availability, and you'll learn about those concepts. And also building things that are non-machine learning applications, like just building a maybe like a Flask app that you deploy, or a serverless, AWS Lambda application. Just building some APIs and just getting an understanding of it is really going to be helpful. I think it's a mistake to think that that's not my job. In fact, when I was CTO, that was the thing that or engineering manager, that's the thing that bothered me the most, when someone we're building something and they're like, "Oh, that's not my job, that's DevOps." It's like, oh, don't say that, like, because it's like saying, the framing of the house, that's not my job. It's like, well, wait, yeah, if the house falls down, of course it's your job. Everybody's job is to build things that are reliable. So I think it's important to think that way when you're doing machine learning, is that you do need to understand there's decades of experience that people have with building software, and they know stuff that you don't know, and you should listen to what they're doing. And probably, if you're really motivated, you could just study what the mobile developer does in your company, or study the web developer and just listen to what they're doing for 6 months to a year, and you could reverse engineer that for machine learning. And they have a lot of wisdom. Like, for example, I can't think of any professional company that does mobile development that doesn't have a build server, right? Like, it would be literally, completely insane to build mobile apps that are production mobile apps that don't automatically get built. So I mean, if you had a developer ad hoc build, like an iOS app once a month, and they're the one person in the company that can build the iOS app, and then they put it to the App Store, that would not work for a very long time. But then people will feel comfortable doing the same thing with machine learning, like, oh, I built this model, it's on my desktop, and like, wait, you can't do that. You have to do the same approach that people are doing in other parts of the company. And I think that's where the shortcut could come, is just follow what professionals, web developers, mobile developers are already doing, and then apply that to machine learning.
Yeah, and then you are able to take those best practices. I think you put it so perfectly there, how there's a lot of experience in this whole software engineering world that can be transferred over. And it's not necessarily a machine learning problem. It's more of a best practices, and how can we learn and take from those best practices and then apply them to machine learning.
Yeah, I think that this whole, like, calculus, linear algebra, part of machine learning is like this good excuse to not do the whole job. And it's like, oh, well, there's calculus, so that means that I don't have to do all the real hard work. Like, no, you do. Like, it just happens to be the thing you're working on requires some math, or some knowledge of math, but that doesn't mean that you get to say, that's not my job for the rest of it. And that's pretty much the worst excuse that you can give somebody, is that, hey, I just do the stuff that is, like, hard intellectually, but, like, the part that makes it work, that's your job. I mean, if someone gave me hints of that when I was hiring them, I would not hire that person.
Yeah, I completely agree with that. I mean, you see a perception, and I think this is common to see on Hacker News threads in our community all over the place, where people, talk about how there is a resistance on the part of people who do pure modeling to do anything else besides that, and to focus on the elegant work, so to speak, of building models, and then saying everyone else figure everything else out.
Yeah, it's similar to, in academics, you see this a lot, is that there'll be places that say, well, we don't do vocational training, we just teach you theory. And there's obviously nothing wrong with learning theory, but to me that's a cop out to say, oh, and yeah, nothing you learn from a master's degree at Duke. I'm not saying anyone at Duke does this, by the way. It's probably the opposite, but if you're like, hey, we got a master's degree, and, like, we don't do anything that gets you a job, it's like, what? Like, why would someone get a master's degree if they don't know any? And the same goes with the modeling. Like, you can't just say, oh, I do all this, like, theoretical work, and then, yeah, the part where, like, you put into production, then we know, we test it, and then we see if the customers want the product. Yeah, that's just somebody else's job.
Yeah, I mean, well, the fact that Duke has brought you on, and that you're at Duke, tells me volumes that they care about making things useful for their students. I think one thing that struck me, especially when you made that comparison, which is, nobody is a mobile developer sitting there and saying, hey, this app, it needs to be built in a specific way. They're built continuously, and they're built with the principle of good software design and software delivery. And I think what struck me there is that growth and that evolution is driven by need, right? When companies started to realize, okay, a mobile app is essential to what we need to do in order to reach distribution for customers, to do things so that we can actually support our business, those principles of good software delivery for mobile and for databases and for all those other areas of software design started to evolve. That growth was driven by need. In your experience working at companies, consulting, I mean, what principles or what realizations do you see trigger business leaders to really realize that, okay, it's not enough to just invest in one-star data scientist or one-star modeler, but to build a culture of software delivery in the machine learning organization?
Yeah, I think that's a good question. I think the real issue that I learned being a manager was that the worst possible way to think about a software team is to focus on individual talent. And even though that's the myth, and there's all these articles, the 10x software developer, and Google is a good example. Hey, we'll whiteboard you for 9 months, and look where that got them. I mean, but I think that what you don't want is people who think they're special and that won't work with other people. You want to have people that work in a team. And so I think that in itself, forget even the domain that you're working in, whether it's mobile, web, machine learning, is if you hire people who think they're better than everyone else and they're smarter than everybody, it's a toxic work environment. And I've been there many times. And it's the worst hires I've ever made in my life were people that wouldn't work with other people because they thought they were better or smarter, or the rules didn't apply to them. So I think that's the big caution I would say. And I'm not saying that data scientists are like this, that's the kind of data scientist I would hire would be someone who not only knows about data science, but also is very willing to learn all the other things and is willing to do whatever the job is, they're willing to do it. Like, and I've definitely hired people like that, and it's just amazing when you hire somebody that's like, hey, what would you like me to do? I'll do anything you want. I'll stock the fridge. I'll dig a ditch. I'll also do machine learning. I'll also do, mobile development. I'll do web development. You let me know how I can help your company. That's the kind of person that I think you want to hire. If you hire someone who's really open to helping everybody and is very team oriented, then you'll have a great approach. I think your product will be a manifestation of that. If you're only focusing on like whiteboard interviewing and credentials and elitism, I think the toxic stew will be very bad in your organization. You might get away with it at Google because, they have so much money and so much prestige that they can get away with it. But I've never worked at Google, but I would suspect that there are sections of it that are very toxic, just because of my experience in hiring people where I've only focused on hiring the smartest people. I bet it's not fun. I bet parts of Google, I don't know, but my guess is, so same thing with when you're hiring people in a company is really personality and character. I think anybody, whether you're Republican or Democrat, would there's a lot of people are saying this now, is character is destiny. If you're a liar or you cheat or you think you're better than everyone else, it doesn't just go away. It will manifest itself throughout your organization. So I think people's character and teamwork is probably the number one category. Given a basic level of competence, it is probably the best thing to look for.
Yeah, I think we had Todd Underwood, the director of machine learning SRE at Google, come in and speak to us a couple of weeks ago. And one thing he said is that, look, we're figuring this out just as much as you guys are. At Google, we're figuring it out, and everyone else is figuring it out. And we're learning from you just as much as you're learning from us. And that dovetails really well with what you're saying, which is a lot of times when we in the machine learning world are sitting at our jobs, we're thinking, wow, Google has this amazing infrastructure. They put out these incredible papers and they put out incredible work, and they do. But that doesn't mean we have to take everything from them. And they wouldn't say that either. And particularly that point on the cultural fits for machine learning work and for particularly to do interesting new kinds of work, the reality is that it's not that glamorous on a day-to-day basis.
And I think what's interesting, if you look at it, for a long time, the tech industry has said everything Google does with hiring is great. And I think we now have a different data point. Again, I think that Google does lots of things that are incredible, but I think we have a now another data point, which is that literally some of the smartest people in the world were hired for a decades, and they produced a product that was so toxic that it actually brainwashed a huge percentage of the population and made them believe in things like anti-vax. Alex Jones, I think alone was served out 15 billion times, I think, according to the Social Dilemma. And you can't just wash that away. You can't pretend that that was not a data point. If I worked at Google, I would be having a reckoning with. And here's the thing where the teamwork comes in, is I really wonder if there were more regular people who are just kind of like, hey, how can I help? I want to be, like just kind of regular, like maybe who had read books that were non-computer science books, like, John Steinbeck or history, or like the rise and fall of the Roman Empire, or where they would say, hey, hold on. Did you look at YouTube? Like we're serving out more traffic to flat earth and anti-vax than we're serving out, like this happened before in the past. Like, so I do wonder if they should have a reckoning in that company. Don't even get me started on Facebook, but with Google, the reason I'm saying that because I like Google, I like the company, and I think that there's a lot of good things that they've done, and they have probably the ability to really think deeply about what they did. But hopefully other companies as well think about this with, facial recognition. If you've trained the model and it's basically trained on people that were, discriminated against and put into prison at a higher rate than other, segments of the population, and then you're using something that's got all this bias built into it, is that really something your company wants to do? Those kind of ethical things, it's easy to kind of pretend like, oh, that's just, that's just ethics, or like we're trying to get customers, but externalities, which is, the fancy word for it. And you see this a lot with startups in the Bay Area, YC Combinator startups, all these startups, is I like a lot of the things that Paul Graham writes, and he obviously a very intelligent person, went to Harvard, but I think he's got a few weak points in there in some of the arguments that he makes, which are specifically, he likes to pretend like externalities don't exist. And a good example would be, Airbnb would be one where, hey, great, we have, housing now is available as a service, but then let's say you're in a neighborhood and then you have a family and you've been living there for 10 years, and now your next door neighbors ride Harleys and they do donuts all the time, or they have wild parties. That was free, right? The neighborhood was safe. That was free. You just stole that. And then now you're selling it. And I think that's a lot of times what you see in the startup world, is that the externality is what is it that's free? Like, let's take the scooters, like
great
Bird
point.
and Lime, those things.
Yeah.
It's like, what was free? The sidewalk was free. You just stole it, and then you just polluted it, and then you're growth hacking. Like, I think those kind of things, just those are ethical issues that maybe in the short term, someone would be okay with doing, but I think in the long term, it eventually will have repercussions. And so I think with whether it's a hire or it's the machine learning thing that you're working on, that the externalities and ethics do matter, even if you're very, very technical. And hopefully companies think about this, because I think that's the way that you can get a good reputation, is by having integrity, and hiring people that work well as a team.
Yeah, this is music to my ears. I don't really mention this much, but I also do a AI ethics podcast. Shameless plug for that. But the the stuff that you're saying goes along perfectly with what we talk about in that, and it's so important as we are moving forward and we're looking at what we want technology to do, that we don't lose sight of that, right? And it's really interesting, this idea that you talk about of we took what was free and then we basically just polluted it, and there's these side effects that people don't look at or we don't think about when we're first starting, and then boom, it's too late. And that's been the story over and over for the past decade, right? It's like, oh, we didn't see this coming, and then how could we have known? And so I've even said this before, like, I don't know, maybe read a book that isn't involved with technology, right? Like the history books or the fall of Rome you mentioned. So I want to shift gears a little bit. I know we're running a little bit lower on time. So I wanted to go into the ecosystem of tooling that is, you mentioned before, like go with a cloud provider or maybe go with some open source. And so first of all, I wanted to just get your opinion on why you thought those, and maybe not some kind of managed service that is a startup, and seeing how there's billions being thrown into the MLOps startup space right now. I want to hear your take on that. And then the other thing is like how you feel about open source tooling for MLOps and where that's going.
Yeah, I mean, it's an interesting question, like the startup MLOps versus the cloud provider. I think it just depends on, like, you could think about it like investing in stocks where, if you bought Tesla in April or March, you quadrupled your Tesla, right? That's lucky, right? That's lucky to do that. Most people buy an index fund because you get 8 to 10%, over time. I think like the cloud providers are like the index fund, where you're going to get great results and it's very predictable. But if you wanted to take a risk and invest in individual stocks, like an individual component of an MLOps startup, you could do that. I personally, at this stage in my life, have taken lots of different bets, and many of them have just not worked out. So, I guess as I've learned is like the index fund approach, where statistically you get a good result over time, is the approach I would choose. And so if in the case of Amazon, for example, or Microsoft, they're so big, you're going to get predictable results. The downside is very low. Just again, with an index fund, the downside is pretty low. I mean, even if there's like a global event like COVID-19, an index fund goes, S&P goes down 40%. That's not horrible, right? Like if you bought an individual stock, it could go down to zero, right? And so the same thing with an MLOps, component, it could go to zero. So you invest in something and it turns out it just doesn't work. I think it depends on the stage of the company. If you're a big company and you're already using AWS, for example, sure, why not? We'll try it out. Try some other tool and see what it does. I personally would not bet my whole startup on some other startup. I mean, who knows what could happen? Again, that's just me. I think the startup tools are awesome, and they can, like Splunk is a good one. Where I remember when they were first a startup company, and I started using their product, and that did turn out. I got lucky, and I did a lot of great stuff with Splunk, and now they're just gigantic company. But I just, again, my approach would be skeptical of betting your whole company on one particular startup product. You don't know the management of the company. You don't know what's happening. I think it's better to treat those as like nice to haves. And if it is some particular problem that it solves and it saves your time, great, go for it. But don't make it the core component of your company. I would bet on the big companies because they're not going anywhere. This is my opinion. People would disagree, but that's my opinion.
I think that makes a lot of sense. There's a adage, right? Don't take a risk where you can lose your shirt. And if with a startup when startups go bust all the time, right? And if they're a core part of your infrastructure, if you're dependent on them to store some data or something, that's a serious risk to your business in the long term. And it's funny because sometimes people don't even take that into consideration when they're thinking about their risk analysis, right? When they're pitching to investors or thinking internally and saying, hey, let's do our risk analysis. Well, what if this provider of this service for us is not there anymore? That's going to cause a lot of disruption and delay. So I think it's a really good point there.
And then here's the other the dark side of you picking something that's like a newer technology that's unproven. Is, are you sure you can hire people to support that technology? A good example, I'll give you one in my career, was Erlang, the language. I did a lot of stuff on Erlang. Worst mistake I ever made because just nobody uses it. Just nobody uses the language. You can't hire anybody. You got to train people. It's just whatever advantages it had, which there's some cool things that Erlang does, it's just not worth it. So that's the other thing, is if you're using some really small product and there's a bigger, like, let's just take SageMaker versus Joe's SageMaker, right? Or whatever it is. Like, everybody knows SageMaker, but they don't know Joe's SageMaker. That could be a problem, because if you need to scale up people very quickly, what documentation do you point them to? So again, I think it's early stages. You have to be very careful.
Along those lines,
go ahead.
I was just wondering about how there was one question we had around like the languages that data scientists should know, and I think you've touched on the idea of, hey, just that T shape and be able to traverse and then go deep if you need to. I'm just wondering, because Go is popular these days. Do you feel the same about Go as you do about Erlang?
No, I think Go is a little bit different in that it goes well, I would say Go is a replacement for Erlang. So Go actually, I know a lot of people that used to be Erlang and then they switched to Go because it is sponsored by a large company. So Google is actively behind it. That's a good sign, right? And then the other one is that it does appear to have a large amount of people that are Go developers. So I think from infrastructure, there's nothing. I think Go is a great choice, probably for many companies, and especially if you're in the kind of web type ecosystem where you're building backend services. I think Go would be a great choice. Now, something like Julia, I wouldn't touch it with a 10-foot pole, because in 10 years, maybe awesome. Julia would be awesome. But at this point in my life, I just, life's short. I don't want to spend 5 years. Then later it turns out that nobody uses the language, and then you can't hire anybody at your startup. That's horrible. I've been there, and it's just, it's not fun.
That's some wisdom right there, speaking from experience. And I can tell the pain. I can hear it in your voice of, man, we spent all this time, we did all this stuff. And then when you need to scale, like you said, what happens when you want to scale up quickly and you need resources, you need talent, and then somebody has to find the people that are out there, and maybe the market, they don't exist because the market's moved on. And so now it's like, all right, we're in a bit of a predicament. So that's a great gem right there too.
Yeah, the one I was going to ask about was Julia, and so it's helpful to hear your thoughts, particularly given your experience with Erlang. I think, just to kind of wrap up, we've talked a lot about how machine learning is going to look a lot like other software fields. I want to kind of flip the question. What do you think about machine learning and MLOps will always remain separate? Why will MLOps stay MLOps and not just DevOps?
Well, that's a good question. I don't know if it will. I think there's a very good chance that machine learning becomes commodity, and that, in fact, it's just something that everyone has to have some understanding of. So I'm not convinced that it will.
And that was actually, oh, sorry, Vishnu. That was one of the questions that I had too, was like, do you feel machine learning is going to be commoditized, and how do you foresee that happening? And is it going to be like, because again, I'm referencing Luigi, he was talking about how you're going to have machine learning be a commodity, but then you're going to need the subject matter experts if you really want to do something. And so the people who have deep knowledge in their respective fields, then you throw some ML on top of that and you can have a product. But the machine learning may potentially be, it's like a machine learning as a service. How do you foresee that?
Yeah, I mean, if you look at certain problems, for example, like classification problem, I mean, really, how much do you really need a data scientist? If you've seen some of these AutoML tools, you give it, a few columns and you click a button and it tells you every single thing that's important. It tells you area under the curve. It tells you, the false positives, false negatives, all this. I don't see why you need an expert at that point. So if you have a deep understanding of the data set, that I think there is a lot of value in that, and that's going to be hard to replicate that. I mean, if you understand baseball stats deeply, then you're going to be better able to interpret it. So it seems to me like the things that in the next 5 years would be important would be that deep understanding of the particular data sets, and then also the ability to use high level automation, and then also how to build the working solution that creates revenue for a customer. If those are, I think, the three things, and that's probably not what many people are thinking about. They're probably thinking about, area under the curve, how to make it better, which TensorFlow, when should I use deep learning?
Yeah.
To me, those three things, revenue, creating solutions, and then also having domain expertise in the data, those are more important than what model you're picking or, how accurate your model is.
Excellent. Well, this has been, I've been typing furiously, just taking notes, because this has been a opportunity that I am not going to take for granted. I understand what a pleasure this was, like, really, for you to come on here, and almost every time you spoke, I was like, oh, we could make that into a quote. Oh, we should quote him on that. And I really love how you look at the different metaphors, like just even talking about, buying Tesla or buying into the S&P, what you just got done saying, right? Like, that is a very, very interesting way of looking at what is happening right now in the ecosystem. And you may get lucky, you may strike gold, or you might just want to go with those 8% returns, and you don't need to get the rich and then or poor, right? So there's a wealth of information. I was expecting no less from you, Noah, and I really appreciate it. Everyone out there listening, I implore you to go check out his website and his YouTube channel. You can check all the links below or in the description wherever you are listening. I think that's it for me. Vishnu, you got any final thoughts?
Yeah, I mean, I think I just want to close out and say your students are very lucky to have a practical person like you be an educator. And to all the listeners out there, check out the Udacity Cloud DevOps degree that Noah helped put together. I'm doing the AWS one. I thought it was really great. And also the O'Reilly content that he has, really, really worth checking out. I know that, I'm going to be sharing it with people in our company. So thanks for taking the time, Noah.
We're all waiting.
Yeah.
We're just patiently waiting for that book to come out. Let us know when it's out, and maybe we can raffle off a few copies to the community.
Yeah, sounds great. Well, it was great meeting both of you, and nice talking to you both.
Thanks again. See you later.